Archiving started.
Hello, this is a review of trace elements, vitamins, iron, and porphyria. Starting with trace elements. A couple different kinds of trace elements. They can be essential or non-essential. Essential refers to the ones that you have to eat in your diet. These samples are collected using a navy blue top tube with a vitamin tube. These tubes are free from any types of dust or contamination that could occur in the environment of which the tube is made. Having these special tubes assures you the fact that you would not have any contamination in your tube from the environment. A couple different types of testing is used: atomic emission spectrometry and atomic absorption spectrometry for these. Let's review each of the different types of elements. First couple, arsenic and cadmium, are types of trace elements which are toxic. Lead, you've heard of lead poisoning, especially with paint chips and things, in children, can be toxic and cause IQ issues. Mercury is another one, which becomes toxic and can cause the same problems. Chromium would be an essential type of a trace element that you need. It is used for glucose, fat, and cholesterol metabolism. We need copper. Copper is involved in several types of processes in the body. A toxicity of copper will lead to Wilson's disease and the Kaiser-Fleischer rings in the eyes. Another type of trace element that you need is iron. I do a total iron binding capacity. Transferrin is the protein that carries the iron. And iron is usually stored in the ferrous +2 state in the blood. The manganese is important for enzymes. That's in each element. Molybdenum is another one. Selenium is essential in the fact that we use it for a thyroid, and if you have too low of a level, it can cause a problem with cardiomyopathy. Zinc plays an important role in enzymatic reactions as well. Pica is a symptom that we can have from having a deficiency to certain elements where people actually eat non-food items, such as toilet paper, rocks, dirt, things like that. Series of vitamins that you have to be familiar with here. Vitamin is the generic name. Vitamer is the chemical name. So, for example, the name of a vitamin would be vitamin A, but the vitamer's name would be retinol. Let's review each of these. Vitamin A is known as retinol. Retinol comes from beta-carotene, and it can affect your vision. So when I talked to my students about this, we decided that the most important stuff is letter A, top, first and foremost, most important. So retinol, meaning your eyes, and vitamin A go together. Vitamin B is thiamine. This is a coenzyme in the decarboxylation reactions and can cause beriberi. Vitamin B2, riboflavin. I think I had a student that mentioned that riboflavin ribs has 2 flavors, honey and barbecue. The 2 flavors in the rib. These catalyze redox reactions, and a deficiency can cause reduced glutathione reductase. Vitamin B3, niacin, can cause pellagra. Vitamin B5, pantothenic acid. Panto means 5. Functions as a growth factor. Vitamin B6, pyridoxine. Think of 6-year-olds as pyromaniacs, and it sounds like pyridoxine. Those promote red blood cell growth as well. It also balances your sodium and potassium. Vitamin B7, biotin. You think of little 7-year-olds that like to play with bionic men. These play a key role in ketogenesis, lipogenesis, and fat synthesis. Vitamin B9, folic acid. Folic acid has 9 letters in it, I believe. A deficiency can cause megaloblastic anemia. Vitamin B12, cyanocobalamin and type issue, deficiency of that, megaloblastic anemia. That requires the intrinsic factor from the stomach in order to be absorbed. Vitamin C, ascorbic acid, deficiency is scurvy. Vitamin D, calciferol, ergocalciferol, or cholecalciferol. Vitamin E, tocopherol, strengthens cell membranes, and vitamin K, which are given to infants to prevent bleeding is known as phyloquinone. Some common deficiency states, which is probably the most important thing if you get anything out of this slide, include scurvy being a deficiency in vitamin C, rickets being vitamin D, beriberi, pellagra, niacin, night blindness, vitamin A, megaloblastic anemia, folic acid. You need to know your fat-soluble vitamins, A, D, E, and K. I always think of addict. My grandma was very fat, and she had an addict, so I always keep A, D, E, K in my head that way. The water-soluble vitamins are pretty much everything else. Thiamine, riboflavin, niacin, B6, B12, biotin, folate, and C. So if you know the fat-soluble, you can pretty much figure everything else is going to be water-soluble. Looking at mineral metabolism, you need to know that calcium and phosphorus are very important with bone mineralization. We're going to talk about that a little bit when we get to that section ahead here. Copper plays a key role. Toxicity can give you Wilson's disease, hepatitis, or fibrosis. Zinc, those enzymes I was talking about. Deficiency can cause diarrhea and loss of hair and alkaline phosphatase deficiency. Selenium and Selena, the movie Selena, I think it's called. This one, and hold on a sec, this is a cofactor to an antioxidant enzyme glutathione peroxidase, which is involved in neutralizing hydrogen peroxide formed during lipid oxidation in cells. Free radicals like hydrogen peroxide will damage that. So deficiency causes cerebrovascular disease. And I think Selena died of, did she get shot? She got shot in the heart, so she died. Her heart stopped. So who kind of made that distinction. Toxicity, though, will cause fatigue, irritability, loss of hair and nails. So you need it to help avoid those free radicals, but too much or too little is not a good thing either. With iron, we know that it's stored in the Fe+2 state, so it can be easily absorbed. With iron, we also do an iron binding capacity. This is the amount of iron that can be bound by saturating transferrin and other binding proteins. A low iron and a high TIBC, you're known as being anemic. So those are inversely proportional there. Low iron, high TIBC is anemia. We usually do a colorimetric method that binds the F. We know it's an essential component of hemoglobin and myoglobin. We need to get it from our food. Deficiency causes anemia. Toxicity can lead to hemochromatosis, which would be too much liver. We typically test for this by doing a hematocrit creatinine hemoglobin and RBC, but otherwise the iron is done spectrophotometrically. So we'll porphyrins for a minute. Porphyrins' role in the body, the main purpose is to combine with iron to contribute to the synthesis of heme. So we need to make heme in order to have hemoglobin. The chemical intermediates in the synthesis of hemoglobin, myoglobin, and cytochromes involve the porphyrin. If we have an issue with this, we end up with porphyria. A porphyria is an accumulation of those heme precursors, and it results from disturbances in heme synthesis. So for some reason, the heme synthesis isn't happening correctly, so porphyrins start to build up. When that happens, we find them in the urine, the feces, and the blood. So here are the heme precursors and how they work. So in order to memorize this, you can read the following. While in delta, porphyrin was heme. So delta aminolevulinic acid goes to porphobolinogen, which turns into uroporphyrinogen, turns into coproporphyrinogen, which goes to protoporphyrin, which then in turn goes to heme, add a globin molecule, and poof, you get. So when we have a porphyria, that is the excess formation of those porphyrins that you see on top of heme, because there's some enzymatic step that is blocked. The clinically that we find protoporphyrin will be found in feces. So feces is like poo and protoporphyrin start with a P. Uroporphyrinogen is found in urine, they both start with a U. Coproporphyrinogen is found in either one. If we find an excess of those, we'll find abnormal heme synthesis. Porphyrinogens are the reduced functional form. They're unstable, colorless, and don't fluoresce. There's a couple different issues that cause a lot of skin issues. Go out in the sun and it really irritates their skin. But if they have the issues, we have a couple names for these. Porphyria cutanea tarda, that's really skin involved. Hepatoerythropoietic porphyria, as it sounds, liver. involves the red cells. Congenital erythropoietic porphyria, very similar. Other neurocutaneous ones that you can have is hereditary corporal porphyria and varigate porphyria. Those would cause neural issues.